Okay, now we're in the classroom. Mrs. Smith's reading class can read an average of 175 words per minute with a standard deviation of 20 words per minute. So her entire class is the population here. So the population mean is 175. That's how much they can read per minute. And the population standard deviation here is 20 words per minute. The top 3% of the class is to receive a special award. Top 3%. It's a small percentage, but they're special. So, okay. What is the minimum number of words per minute a student would need to read in order to get the award? Assume the data is normally distributed. Yes, this is a normal distribution. So that means I can draw my normal distribution and write some stuff in here. Okay, so here's my normal distribution. Here is my population mean right in the middle. That's 175. And each of these represent a standard deviation. Right? So my standard deviation is 20, so 175 plus 20 is 195, plus another 20 is 215, plus another 20 is 235, minus 20, minus 20, minus 20, right? So this doesn't give us any information about the top 3% or anything like that, right? What it does tell us is that one standard deviation away from my mean in this interval here. This is just some extra information I'm giving you, right? And this interval here is about 68% of my values. 2 standard deviations away, about 95% of my values. 3 standard deviations away, about 99.7% of my values. Under this entire normal distribution curve, 100% of my values are there. So this 3%, this diagram doesn't help us for that, right? But I'm going to redraw this normal distribution. And let's talk about how this 3% factors into what we need to do. Ooh, that's ugly. I'm going to draw that over. Still ugly, but a little bit better. Okay. So the top 3% is going to get this award. Let's say this is top 3%. Right? So this right here is the top. This is 3%. Or if I wrote it as a decimal, 0.03. Right? So if this is 3%, what's the rest of this thing? What's all of this here? Wouldn't the rest of this be 97%? 100 minus 3? Or if I wrote it as a decimal, 0.97. Right? Oh, sorry. Right? So this here is the top 3%. And this value, this score here, right in the middle is 175 like I drew before. But this value here is what we need to know. Because this value is the cutoff for the top 3% and the bottom 97%, right? So this is the value that I'm looking for. And in order to get this value, we're going to be using our standard normal table, our z-score table. Because what that'll give us is the z-value. The z-value that yields 97% down here, 3% up here. And then I can convert it back to real numbers, to real life stuff. So I'm going to go to my formula sheet. And I'm going to go all the way down to this standard normal distribution z-score sheet here. And notice something about this table, right? It always gives us the area to the left of that z-value. It always gives us the area less than our particular z-value, right? So these are the negative z-values here on the left, and these are the positive z-values. Either way, this table, when we find a value in here, that's the area to the left of my z, So let's say I wanted to know Let's say my z-value was 1.25, right? 1.25. So I'll go over 1.25 is right here, this value. 1.25, 1.2, 1.21, 1.22, 1.23, 1.25. What that means, right, is if this z-value is 1.25, the area to the left of that is 0.8944, right? 89% of the curve is to the left of 1.25. How does that help us? Well, so remember, the table always gives us to the left. Even though we're looking for this top 3%, the table's going to give us this. The table's going to give us that 97%, that 0.97. So I'm going to look in the body of this table, just like I found. I'm going to look for as close to 0.97 as I can get. I'm going to look for as close to this being 0.97, and then the table will output that z-value. So let's look for 0.97, as close to it as we can get. 0.9719, 0.9713, 0.9706, 0.96. This is as close to 0.97 as we can get, 0.9699. Okay? The z-value that gives us that, 1.88. You see that? 1.88. 0.9699. 1.88. So all that means is this z-value here, this is way too big. This z-value here is 1.88. That's the z-value. That doesn't mean anything to me yet, right? Because I need to solve the problem. So if I go back to my formula sheet, go to chapter 6, what formula is here? Well, they have this one, z equals x minus mu over sigma. So let's write that. Now, you might remember, depending on how much you remember from the lectures, you might remember an alternate version of this formula, where you're solving for x. X equals z alpha plus mu. That's if you solve this for x, right? Cross multiply z alpha, add mu. You can use either formula to get there, right? And I'll use both of them. Because we know x, right? Whoa. Yeah, we don't know x. Sorry. We know the population mean. We know sigma. We know our z value. Z, let me write it in blue. Z equals 1.88. The z value that gives us 0.97. We just need to find x. We need to find a real life number. And then we're done. So if I'm using this formula, 1.88, that's my z value, equals x minus 1.175 divided by 20. Okay, and I'm solving for x. So I'm just going to cross multiply and get it over with that way. So cross multiply, so x minus 175 times 1 equals 188. 1.88 times 20. X minus 175 equals, what's 1.88 times 20? Well, let's see, 188 times 2, that would be 376, right? So 37.6, add 175. And I didn't line that up nicely, so it looks kind of weird, but whatever. So that's 212.6. Even if I do it this way, x equals z 1.88 times alpha plus mu, which is exactly what I have there, right? 1.88 times 20, that's 37.6 plus 175, that's 212.6, right? I hope that's right. Is that right? I think so. Should be. Okay, so I can't use 212.6 though, right? Because it's how many words per minute you're reading. So you're going to round this up. So 213 words per minute. That's your cutoff. That's what you need to read in order to be in the top 3% and get your special award.